Well, it's not going to graph right, obviously.
We'll make it work.
I ate leftover ribs for Mother's Day. I had chicken, wild rice, whatever. Think of ribs, it's just disgusting. But when you eat it, it's so good.
All right.
But they're not my favorite. Yeah, they're not my favorite. I like steaks.
Well, that did it. Okay, so what do you have for the bottom? So two numbers. Working now for some reason. Two numbers that multiply to 5 and add to -6. -1, -5. There we go. So give me something you know about this graph. Does it have any holes? No? How do you know? Nothing cancels. Does it have any vertical asymptotes? Where are they? 1 and 5. Does it have horizontal asymptotes? And if so, where? Y equals 0. Degree of the top is less than the degree of the bottom. And that's the stuff we know is not going to show up on our graph, except maybe the horizontal asymptote. So let's get that on there. Here's our vertical at 1, 2, 3, 4, 5. And y equals 0 is a maybe. As I mentioned yesterday, that's the weird thing about horizontal asymptotes. Sometimes they get crossed. It just happens. All right, that's what we know should not be happening on a graph. So next, let's find some points that should be happening on a graph. X-intercept, something, 0. Where do you go to find this? You have to think, how could this come out to be a 0? And that's what we're looking for. So we're trying to figure out, where do we go for the x-intercept? Where what equals 0?
Y.
So how do you make y equals 0?
Plug in a 0 for Y. So,
Get out the L sheet I gave you yesterday.
make
The more you have to look it up, the more you're going to remember.
is it negative 3? Oh, it's in the numerator.
Remember, we used up all the information from the denominator that we could get. And that's not where a 0 is going to come from. A 0 can be on the top, in the numerator. The bottom, no, that's our vertical asymptotes in our hole. So we go to the top of the fraction and say, what would I put in here that would make this 0? And next up
I got it right.
would be the y-intercept.
What did you just find? Wow.
You make everything 0 for X.
Then it's just 3/5.
So there's a couple points that absolutely will be on our graph. -3, 0.
See, my memory's not too bad.
And now we see it. It's going to cross our horizontal asymptote. It happens. Hyperbolas, this one's breaking the rules. It's breaking the rules.
Funny stuff.
Just does it. So now what we need to do is make a table, find some numbers.
That was funny.
Can everybody see that vertically this has been chopped up into 3 different sections? Vertically we're going to have something happen over here, something in between here, and another something over here. Now it is a hyperbola, so we're hoping for a couple of branches somewhere that make sense, but right now this is already breaking rules by crossing that horizontal asymptote. So we grab the graphing calculator, we go back up here.
We look at it, and then we put it into the table, right?
That's exactly what we do.
Yeah. Thanks.
Rather than putz around with lots of points. Oh, does anybody need a calculator again? Anybody need one?
You do? Rain a little bit though, so it's probably.
It's get her in there and see what happens.
That's really too bad. My grandma's gonna be at 225.
So parentheses, x plus 3, parentheses, divided by parentheses, x squared.
Or
Shh, guys, focus.
alright.
Loom 6. So we had a couple of hyperbolic branches there. But really weird about what's going on in the left. So what I would want to do is go to my table and say, okay, as I go negative here, is it crossing? I mean, if you look right there, it says -2. It's still a little bit above because it's still positive. Uh-oh, it did cross.
Uh-oh.
It
That's
did.
not good.
You see negatives, it happens.
Wait.
So it's actually a little bit below the
Because
x-axis.
it came across the...
Horizontal asymptotes, it happens, unfortunately. Kind of
It
breaks
doesn't
the
cross the-
rules.
It doesn't cross the vertical.
Nope, it does not. Now let's get some numbers for the middle piece there. So something like 2, 3, and 4. Question, Eli? He's good?
She asked if you had a question.
Oh, really good.
Okay.
I'm good.
Are you
Are you okay?
sure?
All right, so at 2, we've got -1 2/3. At 3, -1 1/2. At 4, -2 1/3. And then, yeah, just take another look at the graph so you can make sure, yeah, it's going down, because we know it's going to approach the asymptotes.
Wait, how do you check the data table for the separate lines? Separate,
We take a look between what's going on at 1 and our other asymptote, which is going to be 5, and see what's happening there. And then we need some stuff over there beyond 5. So, second table, 6, 1.8, and 7, I'll just put 0.8 repeating. We can change that back to a decimal, but or fraction. It doesn't make any difference. We just need to be able to graph it. So 6, 1.8, almost 2, 7.83. So now, knowing that hyperbolas tend to have those 2 branches that are symmetric, I would be worried that maybe that's going to dip below that axis, the x-axis going in the positive direction.
How do you find the exact... horizontal estimate? Like the exact...
we did.
We found it. It just doesn't work for the whole graph. That happens with horizontal asymptotes. It'll work for portions of the graph, but not the whole thing. Like, for instance, the horizontal asymptote's working fine here and here. I can see it's never going to cross the x-axis that way. But this is just one of those weird ones where something's going on as it goes up to the left here.
It's alright. It just doesn't feel
So-
right, you know?
No, it doesn't. It feels like you did something wrong because the asymptotes are not supposed to be crossed, but horizontals
Too
do.
bad, is it? I know, it just messes with your mind.
All right, now,
Throws your brain for a loop. is what it
Because
does.
what we're supposed to do is all of this good stuff first, and then just grab the graphing calculator at the end, because the algebra is what's supposed to be our focus. And that's the reason we let you grab the calculator to get the rest of it as we go through that. And speaking of the calculator, we're going to have 2 lovely ways that we can do this beautiful problem.
Man.
And what is point?
Look at that. Using a rational function. You work at a pharmacy that mixes different concentrations of saline solutions for its customers. The pharmacy has a supply of 2 concentrations, 0.5% and 2%. And then it says, let me turn over just a little bit, that humongous function that we see right there models that. And this happens all the time because medications that are used for adults, if they're trying to save a baby's life, they're going to try some of those meds on babies. But usually medications are given by weight. So obviously an adult's weight needs to be pared down for a child. So this gives the concentration of the saline solution after adding X milliliters of the 0.5% solution to 100 milliliters of the 2% solution. how many milliliters of the 0.5 solution must you add to the combined solution to have a concentration of 0.9%? Wow, that's a lot of blah, blah, blah. Y gives the concentration of the saline solution. So we want to know, when is Y
Just plug in different values
this?
for different things.
But we have to use decimals, not percentages. So what do we have to do to our little 0.9%? 0.009. And now I'm thinking ahead to, if I do want to use my calculator, I'm not going to punch in 100 times 0.02. When you multiply something by 100, it moves the decimal 2 places. So this would actually be a 2 plus 0.005x over 100 plus x, or x plus 100. That doesn't make any difference. If I do choose to use my graphing calculator, I'm going to want to put parentheses around everything in the top and parentheses around everything in the bottom. Now, why do I say if I did choose? Could we solve this algebraically?
Absolutely.
Absolutely. Slap a 1 underneath this, do some cross multiplying. You know, you're going to be working with some nasty decimals, but you definitely could show the algebra that would do this. Now, like I said, there's 2 ways to do this. You can do it algebraically, and I know you are able to do that. Or we could go back to Blinky.
Blinky. I think I'd rather just cross. Yeah, this one seems.
And you know what? This is one of those where it is a little harder to figure out the window. Because does anybody know how big a milliliter is? Because we're talking about milliliters of liquid.
Big. Milliliters are pretty small.
A milliliter is, if you've ever had eye drops, and you know how you can get 1 drop to come out at a time, that's about the size of a milliliter. So you have to know that stuff in order to get this window right, so that you can figure out, where does all of this hit. Now I am going to do it with the calculator because I know you guys know how to do it algebraically. But we've got the 0.009, which also creates problems in the window. And then we have parentheses 2 plus 0.005x parentheses divided by parentheses 100 plus x parentheses. So the window is really the problem with this one. So you need to know that if they're going to water this concentration down, they're going to need a lot of milliliters. And in fact, usually, if you've ever visited anybody in the hospital, you look at those bags that are hanging, and a lot of them are 500 milliliters to 1,000 milliliters. There's a lot of liquid in there. So I would try 1,000 milliliters. And then, like I said, here's the other problem. We need to see 9 1,000ths. If we even just put 1 in here, we're not going to see the graph we want to see. Look at this. 1 is too much. We see nothing. So 1 is too high a number for y. So let's try 0.01. See, maybe, just maybe, we can start to see some of this graph. Well, there's our 0.009, which is good. And yeah, now we can use Blinky. So this is one of those that would take some thinking in order to get that window that you'll be able to see and know that Blinky can tell you what's going on. And then everybody remembers second trace, number 5. Enter 3 times. Blinky says 275 milliliters.
That's what I got. Great.
You did get time.
I got 275 too.
Yeah.
And
And that is the method I would probably use with these, especially if you don't know about all the little stuff in the problem. Then just say, you know what, algebra time. I'll slap a 1 under here. I'll cross multiply. Yet granted, it's nasty decimals, but
It's not good at it.
in the end, it works out really nice. So this one I'm going to leave up to you, and I'm going to give you a candy partner. And this is just a totally ridiculous problem. For some reason, you apparently don't like 100% pure orange juice and you want to water it down.
Yeah, I do like it.
You're going to take some 10% orange juice drink with 100% pure orange juice drink because you want 40% orange juice. I don't know why. So here's the little function that we have here, very much like the pharmacy example. But this time, notice X is in gallons. How big is a gallon?
Pretty big.
A gallon of milk. It's pretty big. So your window probably won't be as difficult to figure out with this one. totally up to you if you want to set this up and do it algebraically or do it with the graphing calculator. But I'll get you a candy partner, so either way you two can check each other.
I do not like crap.
Yeah.
I just like what pencil. Why do you? What's the sign? That's 4. Yeah.
Thank you.
Okay. How much crap? I love crossball. That's my favorite.
That's feeling good.
It's really fun. Yeah.
Don't say anything. Candy partners, remember?
I like Algebra.
I just love some classic salt.
Yeah. Just refreshes the brain, especially early in the morning like this. I mean, it is.
The 10%, would you have to add? 4 gallons.
You monster.
And again, you could slap a 1 under there, you could cross multiply, get what you needed, or you could y sub 1, y sub 2 this. Now, B says this. B says, if you wanted a drink that is 80% orange juice, mind you, this one was 40% right here, would we only add 2 gallons? Does it make sense that we would just add half as much of what we have? Talk to your partner, what do you think?
Yeah.
I am going to say it sounds pretty good.
All right, here's what I need you to do, because I heard a lot of wrong answers out there. I want you to look at this right-hand side over here. Does that look like something we're just going to be able to multiply by 1/2 and things will work out nicely?
No.
You can't do that with mixtures. It doesn't work that way with those concentrations. So, no, we cannot. We would have to redo the mathematics behind it and make sure that everything's going to work the way that we think it's going to work. In fact, if you went through and put a 2 into this formula, you'd see that's not going to come out to give that 8%. All right. Thank you, partner, for the help.
Just all those sound effects.
That's hilarious.
You're my Snapple fact.
Hey, Mrs. Senior Home, do you want to hear a joke?
Sure.
Why'd the cactus cross the road? Oh my god.
Why did the cactus cross the road?
This is actually really funny.
I don't know, because a cactus can't really cross the road.
It was stuck on the chicken's back.
Oh, the poor chicken.
Better joke? My GPA.
All right, let's take a look at number 1 on the 8-4 worksheet. Let's see if everybody remembers what we were supposed to do. Because we did cover, let's see, we took 2 days on 8-4 and 2 days on 8-5 earlier before the MCAs and ACT. So simplify each rational expression, state any restrictions on the variables. I do.
I think if we just do one, I can remember, but. Oh, x plus x plus. Oh yeah, 2x plus. Oh, they cancel.
Oh yeah.
And then we're left with 2. Man, that's math. Isn't math? I remember this
That's
already.
cool math. Now, the
I
one
love
thing
this
we're
stuff.
probably really rusty on is restrictions on a domain.
X doesn't equal -3. Wow,
That denominator cannot equal 0.
that was impressive. Thanks.
So anything that you have in the denominator, start of the problem, middle of the problem, at the end, you have to state as a restriction on the domain. So that should clear up 1 through 8 for you, right?
That's fine.
Let's go down to
4, 9,
number 15.
Number 15, you say.
Number 15.
Oh my.
Well, first thing you gotta do is simplify.
Yeah, make that one fraction.
Oh, I'm saying back.
What are you thinking? Oh yeah, factor like crazy. Whatever you can factor, you factor. The first thing you see is it's multiplication, which is good news. Multiplication means if we can cancel something, we should do it. But we need to factor. Obviously, there's nothing we can do with that. That's already multiplication. This is a difference of two squares.
X plus 5 and X minus 5.
How about up here?
X plus 5 and X plus 1.
But anything in the numerator can be canceled 1 for 1 with anything in the denominator, as long as you have multiplication all the way through the problem. So, what do you think? Take this out?
X squared out.
You can. Don't forget you have one left over up there. Now, the reason you don't scribble is because you need to see those restrictions on the domain. Anything that's in that denominator that would make it 0 has to be left out. So domain restrictions. Negative 5 is positive 5. Oh, why 0?
Because of the X squared on the other side.
Alrighty. Uh-oh. Divide.
We do reciprocal.
So let's start with 17.
I have a feeling you're going to throw a snorkel out of nowhere. It's going to be like, Billy has 3 sandals, Susie has 12 jeans. They put them together, let's talk to the sun. Y equals 6.
7x to the 4th over 24y to the 5th divided by 21x over 12y to the 4th. Now the first thing is, this is not multiplication.
No, it's division.
So what do we do? Okay, so let's change it up.
Yeah. It's division.
Now, it's up to you whether or not you want to make this one fraction and then do all the reducing, or if you want to cancel and cross-cancel. Sometimes it gets hard to keep track of everything, but if you write clearly and keep it organized, it should be okay. The 7 into the 21, 12 into 24. What else? One of those x's can come out. Y's. Now, you notice how this got really messy really fast. And if you write really messy, you're going to have a lot of trouble with these problems. So if you know that you're going to, just don't write that legibly and you know you're going to mess up, then just do top times top, bottom times bottom, and then do all of the canceling as you go through there.
Yeah.
What do we have left?
Have more space. So 6y.
That's why you have to be really careful. Yeah, there's just so much to keep track of. So yes, we do. We multiply by the reciprocal. Domain restrictions.
Y equals 0.
Well, where's x in the denominator? Yeah, again, you check at the beginning, you check each step when you have a new denominator. So it's not just the y. X also can't be 0.
That's good stuff right there.
That is very good stuff.
See, we know the homework. Yeah, so therefore we shouldn't do it.
Exactly.
I agree.
I totally agree.
Well,
Let's take
it's
it
a
to a
good thing
vote.
this is a dictatorship. Because
No, I
what
mean,
you're
like-
going to do is go back and finish up the word problems from the homework that we didn't get to yesterday. It was something and then 39 to 41.
35.
35? 39 to
39.
41. Okay, you're gonna finish those up, and then you're gonna do the circled only on just 8-4. Don't do 8-5. You'll make me have to get another worksheet and give you more work to do. Just the circled ones on 8-4. And we'll have those done. And then tomorrow will just be 8-5.
Right, we're doing the circled ones.
On the front and back of the first page. So this and that.
So can I just do the entire packet tonight?
No!
Why not?
Because then you'll make me give everybody else another worksheet on top of this.
Well, maybe I'm
Circle.
doing extra me.
That's a ton.